Welcome to the third and final installment of the day Tony missed in linear algebra. Okay, so before we looked at R2, we looked at R3, now we're going to look at Rn and define equations that we can use in the Rn space. So, say we had the linear equation a1 x1 plus a2 x2 plus dot 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 plus an xn equals b. Say we had this linear, and we've seen this 100 times before. We've seen this, if we had n amount of equations, we could solve this and we would have one answer, or if we didn't have exactly n amount of equations, we would solve this and we'd have infinite amount of answers, and we'd define that with a free variable or something like that. But anyway, this is right here, this is an implicit equation. We are implying that we are solving for these variables. What we want to do is we want to split this into an explicit equation. So, and this will help you if you review your rules of vector multiplication and vector addition. This will help you to do this. So we're going to split this up into an A part and an X part. And all we're going to do here is we're going to take A1, comma A2, comma dot dot dot, comma A, N. And all we did was take all the A's out of this. And over here we're going to go x1, comma x, comma x. That doesn't make any sense. Let me erase that. Where's my eraser? There it is. Which is the sound the eraser would make. Anyway, x1, comma x2, comma dot and dot and dot, xn, comma. And all we did was take the 1, the 2, the n, and there you go. And if you don't know how to do this, if you need to review your vector addition and multiplication. So, in essence, what we can say here is that A times the dot product of x, or A dot product of x, equals B. And this is very important here. And what does A dot product of x mean? Well, this simply means, well, we're going to take A1 and fuse it together with its corresponding part here, which is x1, plus, and we're going to sum up all these factors, A2, x2, and we're going to sum up all these factors. We're going to multiply these A and these x together, and we're going to sum up all these factors. So we're taking the dot product there, and that's what we're doing. And then that's what A dot product x equals B means. And this is to solve a general system. This is to solve a general system. Now, what about if we wanted to solve a homogeneous system? Homogeneous system. Well, what do we know about homogeneous systems? They always equal 0. They always equal 0. So that means A dot products x is going to equal 0, and that is going to define the system homogeneously, where obviously B is equal to 0. Now this isn't, we really don't even need, it's like in the other video where I said, okay, well, if we start at some point here, we'll start at some point x, and we go to some point y, then we'll say this is line W, and I haven't made any steps while I start at x, and as I continue to y, as I approach y, I haven't made any steps previous. Well, what does W equal? W equals y, because x doesn't mean anything. It's 0. I've started at x. So that's basically what this is saying. And what do we also know about homogeneous systems of vectors? They are orthogonal. They are orthogonal. They happen at 90 degrees. So that's why this is important to define. Otherwise, you really wouldn't need it. Like, so what if it equals 0? We're going to do the same procedure, but so what if it equals 0? Well, they are orthogonal. And you have to know that we started at the origin here. So this is carried through all throughout these lectures, and if you please grasp that and think about this, do whatever you have to do to grasp that. But we also know that any homogeneous system of vectors is orthogonal to each other. Okay, moving on. So what we're going to do now is we're going to prove, given this information, that A dot product of x equals B. And you're, well, you don't really need a proof of that. You saw this here, and like that seems fairly intuitive. But we're going to prove it anyway. So we're going to let x be the solution to a general system. And a general system was defined by A dot x equals B. Nothing confusing there. And now we're going to let x naught be the solution to a homogeneous system. And that's defined by A dot product x equals 0. And then we're going to take x naught plus x and see what happens. Now, we're going to say that this is going to equal the general system. So that's basically A dot x equals B. So we're going to say really that this is equal to B. Now I want you to think about that for a second. And I want you to think about how obvious that is, because when you multiply anything by 0, it becomes 0. So if you had A, and we assume A is a number, and we assume x, and we're assuming that's x naught down there. If we assume A is a number, x naught has to be 0 in order for this to get 0. If we're multiplying these two, has to be 0. So if we look at this, and then again, this is another installment of, okay, we're at point x naught, and at this point we haven't traveled at all, and we're going to go to point x, and we'll say this line is point f. Well, what's the value of f? The value of f is x, because we haven't traveled at all before this line. So the value of this line has to be how much you've traveled. And this is just another installment of that, because if any number times 0 is 0, and we assume that x is a number, and so we assume that A is a number, and x would have to be 0. So if x naught is going to be 0, if x naught is the homogeneous solution, this is going to be 0. So let's times it by A, and we'll see what happens. We'll say x naught plus x. We'll multiply that A, and because vector multiplication is distributive, we're going to wind up with ax0, and we're going to wind up with ax. And okay, well, what's ax0? Well, we just defined that ax naught in a homogeneous solution, because we said let this be homogeneous. So let me write that out. We'll say this was homogeneous, and this was general. We'll say in a homogeneous system, ax0 is 0. So this must be 0. 0 plus ax. And what's ax? Well, if we look over here, we said in a general system, ax is b. So this must be b. Because 0 plus b, well, let's back up a step. Because this is 0 plus b. Because this has to be b. Because this is a general solution. What's the answer to a general solution? B. So this is b. And that's very simple, and it's all based on this principle that if you start it somewhere, and then you keep walking, you start it somewhere and you haven't made any steps before that, and then you walk to a point, the value of how far you walked is the value of how far you walked, which is that point. So I hope that was helpful for you, and that is the last installment of what Tony missed in linear algebra on day 23. Thanks for watching.